Hey guys, today we are going to talk about similar polygons. Similar polygons are polygons in which corresponding angles are congruent, but corresponding sides are not congruent, they are proportional. Okay, so that means angles are all the same size, but the sides are not. Okay, so congruent angles means same shape. Proportional sides, though, means different sides. Okay, so different side lengths, which actually means different size. Okay, so they'll be the same shape, but different size. So in this diagram here, triangle ABC is similar to triangle DEF. Okay, so similar is just that squiggly. Okay, so no equals underneath like congruent. So the triangles are similar. So we're going to list all pairs of congruent angles, and I don't even need the picture for this. In corresponding order, angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Okay, so this similarity statement is written in corresponding order, so I know that the congruent angles come in the corresponding order. Check that all the ratios of corresponding side lengths are equal. Now, if they are going to have proportional sides, that means that all the ratios of corresponding sides will be equal. Okay, so we'll do side AB over side DE, so 10 over 15. Okay, and what does that equal? So we're going to simplify that. 10 over 15, that's divisible both by 5, so that is 2/3. Okay, then BC over EF, 8 over 12. Okay, and 8 over 12, those are both divisible by 4, 2 times and 3 times. So notice that the ratios are the same. And then AC over DF, 12 over 18. And those are both divisible by 6, 2 times and 3 times. So each time we got the same ratio. Okay? By the way, that means that the scale factor is 2 to 3. Okay, that ratio that they all simplify to is the scale factor. Write the ratios of corresponding side lengths in a statement of proportionality. Okay, so that statement of proportionality is going to look like this. Side AB is to side DE as side BC is to EF as AC is to DF. That is the statement of proportionality. Okay, so here, without a diagram, I know two triangles are similar. List all pairs of congruent angles. So angle P is congruent to angle X. Angle Q is congruent to angle Y. And angle R is congruent to angle Z. Okay, the side lengths are not all going to be the same, so there's no congruent sides, but they are proportional. So we're going to write a statement of proportionality. PQ is to XY as QR is to YZ. Okay, so that's the first two letters, and then the next two letters, and now the first and last. PR is to XZ. Here we want to determine whether the triangles or whether the polygons are similar. If they are, we will write a similarity statement and find the scale factor. Okay, so we need to match up corresponding sides and check their ratios. So we've got AB, that's between a right angle and a single arc. So that goes with JK, so 8 over 14. Both are divisible by 2 4 times and 7 times. Okay, so if all the other ratios are also 4 over 7, then the triangles or the polygons will be similar. Okay, so then let's do AD. That's between the right angle and 3 arcs. That goes with JM, so 12 over 21. Both are divisible by 3 4 times and 7 times. BC, between 1 arc and 2 arcs, goes with KL. Okay, so that's 8 over 14. Both are divisible by 2 4 times and 7 times. And then DC goes with ML, and that is 8 over 14, which also simplifies to 4 over 7. Okay, so are they similar? Yes, all the sides are proportional because they simplify to the same ratio. So yes, they are similar. Write a similarity statement and find the scale factor. So A, B, C, D is similar to, so that's A, B, C, D, J, K, L, M. Okay, so that is the similarity statement, and find the scale factor of A, B, C, D to J, K, L, M. The scale factor is 4 over 7, but we need to make sure that it's in the right order. A, B, C, D has to be represented on top. A, B, C, D is the smaller figure. We have the smaller number on top, so the scale factor is 4 over 7. Now, if it asked for the scale factor of J, K, L, M to A, B, C, D, that would be 7 over 4. In this diagram, the two triangles are similar. Find the value of x. Okay, so x is right here, and x corresponds with 13. Okay, now x is on side ST, and that corresponds with CD, which is 13. So x is to 13 as, okay, now I went with something from this triangle in the numerator, so I need to stay with this triangle in the numerator over here. And I can do 24 over 12, or I can do 10 over 5. Let's just use the smaller numbers. So x is to 13 as 10 is to 5. And I can use cross products to solve this. I get 5x equals 130. And I can divide by 5 and get x equals, so we need to check 130 divided by 5, and that is 26. In this diagram, FGHJ is similar to LMNP. Find the scale factor of LMNP to FGHJ and the value of x. Okay, so LMNP is this one over here. I need to pick a number from this figure for which I have a corresponding number for this one. So I couldn't do like x is to 40 to find a scale factor, but I could do 12 over 15. Okay, so to do LMNP, something from LMNP over its corresponding value from FGHJ, 12 over 15. Okay, now 3 goes into both of those 4 times and 5 times. So the scale factor is 4 over 5. Okay, so we were asked for the scale factor, so I'll put that in a box. That's part of my answer. And then find the value of x. So I've got x is to 40 as, and I could do 12 is to 15. I could do this 12 is to 15. I could do 16 is to 20, or I could do the scale factor, 4 is to 5. So I can pick from any of those options. 4 over 5 is the smaller set of numbers. And any other numbers I pick, 12 over 15, 12 over 15, 16 over 20, would all simplify to 4 over 5 anyways. So I have 5x equals 160. And divided by 5, 160 divided by 5 equals 32. Okay, perimeters. And I have perimeters spelled incorrectly. There shouldn't be an I and an E there. Okay, so I'm going to get rid of that I. Perimeters. So the perimeters of similar polygons theorem says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So if KLMN is similar to PQRS, then if I add up all the sides, that's the perimeter of KLMN over the perimeter of PQRS is the same as any ratio of corresponding sides. So KL over PQ, or LM over QR, or MN over RS, or NK over SP. Okay, so these ratios are all the same as the ratio of the perimeters. Each one of them would simplify to be the scale factor. Okay, so a larger cement court is being poured for a basketball hoop to replace a smaller court. The court will be 20 feet wide and 25 feet long. Okay, so the new court will be 20 feet wide and 25 feet long. The old court was similar in shape, but it was smaller. It was only 16 feet wide. Find the scale factor of the old court to the new court. Okay, new to old. The new court to old court. So that's going to be 20 over 16. And that can be simplified. 4 goes into both of those 5 times and 4 times. So the scale factor of new court to old court is 5 to 4. Find the perimeter of the old court and the new court. Okay, so the new court. It's going to be kind of easy to get this perimeter because I know there's a 20 here and a 25 here. I can add those all together. So 20 plus 20 plus 25 plus 25 is 90. So the perimeter of the new court, is 90 feet. Okay, we still need the perimeter of the old court. Okay, so here's one way that we could do it. We could say the perimeter of the new court, 90, is to the perimeter of the old court, x, as the scale factor is 5 to 4. Okay, so remember we did new to old in our scale factor. So we have new to old equals new to old. So I can do cross products and get 5x equals 360. And when I divide by 5, so 360 divided by 5, I get x is 72. Okay, so 72 feet is the perimeter of the old court. Okay, so perimeter of old is 72 feet.